So my name's Elise Iden, and I work as a senior member of technical staff at AT&T on our OpenStack Helm development team.
I'm Doug Schevenger. I'm a principal systems engineer. I work on the full CD and the Aqua team, and we'll talk a little bit about what Aqua is. But we'd like to welcome you to QA automation in the Kubernetes world.
So first off, to give you guys a little bit of a rundown of how we're going to set up this presentation. First, we're going to briefly cover AT&T's evolution from AIC to what you've heard referred to as AT&T's network cloud. And then we're going to talk about how we've tested our cloud throughout the entire containerization process. Then we'll talk about how we utilized and extended our existing AT&T test platforms so that we could use them with our deployment tool, OpenStack Helm. And then we'll go into a little bit of our plans for future testing efforts. So first off, as I'm sure you've heard, network cloud is the next step in the evolution of AT&T's cloud. So it runs network workloads on fully automated, containerized OpenStack deployments. So it is comprised of OpenStack Helm, which handles the deployment of the containerized OpenStack cloud, and then what you just heard referred to in the keynotes today as Airship, which handles sort of the lifecycle management of that cloud once it's deployed. So that sort of results in better resiliency, better scaling, reusability, and faster and more predictable deployments based on the fact that we're using things like Helm and Kubernetes, and we have their native functionality and features that we're able to use and take advantage of. So all throughout the process of developing network cloud, we are promoting quality. So a bunch of different ways that we're doing that. First of all, it's been open source since the very beginning. So it started and continues to be, and it's just a collaboration between a lot of different companies in the field who are leaders in computing and networking. So we have lots of eyes on this code, and we have since the start. It's also designed for operational excellence. So the way that software changes happen within our network cloud is that it follows a totally predictable process. And there's a lot greater control over our deployments and less likelihood of any sort of configuration issues due to that. It also evolves our local control plane security. So there's only one way to introduce changes into our system, and that's by pushing some updated manifests into Shipyard, which is an Airship project. The endpoint is very carefully controlled. We also have, since it is containerized, it ensures that processes are running in isolation rather than all side by side in a single host. And lastly, we also are evolving our AT&T test frameworks within network cloud. So we can utilize the things that we already have that were container ready, and Doug will discuss those in a little bit more detail. But in this transition, we're not sacrificing any of the quality that we worked so hard for in AIC as we change to network cloud. So first I want to give you guys a little bit more detail on how OpenStack Helm as a project itself actually supports good QA practices. So first of all, we utilize the Helm Deployment Manager, which has already integrated different ways to test charts. One example of that is Helm Test, which is just a basic sanity check test that you implement yourself, or if you're using Armada, which is a project within Airship, it creates a Helm test for you as you spin up each component, which makes your deployment a little bit more secure. It's also possible to test other software using the deployed OpenStack Cloud. We have a patch set out right now that introduces some upstream keystone gates that allow us to use OpenStack Helm to test some LDAP integration. And we also have all of our internal CI/CD that runs in and manages an OpenStack Cloud that was spun up by OpenStack Helm. And simply by using OpenStack Helm, users can also run a real prod-like OpenStack environment on their laptops, which is sort of contrasted a little bit with DevStack, which lets them test things like resiliency and rolling upgrades that they would usually be able to test on an actual site. I'll hand it over to Doug.
Thank you. Now that you have a high-level vision of what we did in our environments to transform, let me talk a little bit about what we did to transform testing. Previously, we had unit test, system test, end-to-end test, acceptance test when the deployment was completed, but they happened at different corridors. So they might have happened, and usually later on in life, in our patch set corridor, our development lab, our RC lab, our system test lab, or our system introduction lab. The problem with this testing approach is those tests occurred later in the life cycle. And when you test later in the life cycle, the cost of refactoring, correcting, and retesting basically slows down your delivery. Basically, the backload of delivery cycle, the defects require further testing and keep going and increase the cost of your deliverables. So basically from seeing this, we saw that we had no standard test runner to share tests across the different organizations inside of our program to basically identify what happened. So what we did was we basically standardized on a set of test frameworks we call Aqua. That's preliminary effort to shift the testing to the left, including development of the Aqua testing framework for more earlier and diverse testing integration. These tests would happen as soon as possible, and the same test framework would allow you to run those tests throughout the different corridors. Previously, our different organizations tested things using test plans and maybe a manual CI or CLI approach or even a Horizon approach. We had two different approaches of Tempest. One was an older version, one was a version based off of Juno, which was the release that we started with. And we even have people looking at a Kata one and a Kila one. And we just basically said, hey, this is not working for us. There's just too many different copies. Can we come up with a strategy to take care of that? Along with this strategy, I'll explain it a bit, Helm Test, Kubernetes Health Check, and the testing framework called Aqua allows us to eliminate problems as soon as possible. Let me cover a little bit about the Aqua. I'm sorry. So basically on the Helm Test, on the Helm Test, let's go a little bit over the Helm Test. Helm Test basically is an OpenStack Helm chart, has a test section that tests the deployment of the chart. These tests can confirm the necessary container services and resources are functioning for this chart. On the screen right now is the Cinder chart. You can see that there's just one test in here, and that test is to create a volume and to delete a volume. This, in my opinion, is the perfect test to test that the actual chart is working, because it basically interacts with Keystone for your token. It talks to the Cinder API service, who talks to the scheduler service, then the volume service. And in doing that, it also talks to the SQL backend and your messaging resource. So on a Helm test, you just want to make sure that that test basically allows you to confirm that that chart is functioning from a deployment perspective. Then comes in the Aqua Framework. Aqua stands for AIC Quality Automation. It represents an extensible test framework that spans various dimensions of the delivery lifecycle required to have a confidence in delivering a stable platform. Aqua seeks to establish a consistent and continuous testing across the organization, and like I say, those corridors. The different Aqua frameworks have a set of principles that we try to promote to utilize sanctioned open source test frameworks like Tempest, Shaker, and Tox. Extend and contribute upstream. Integrate in the CI/CD gates as soon as possible. Make sure that the CSO compliance for testing and certification mechanisms are met. Assure that each execution cleans up its resources. Make sure that the functional integration tests call and assert meaningful results in the API. A lot of this is coming to where if we're having a single test bed, we're talking more about our tests. And we're starting to make sure those tests actually provide value instead of meeting a test plan perspective and making sure that it's a repeatable value. Also, we provide development tools, documentation for the development of the tests. We originally created this as a container framework to run in our automation, and then we found out that we have to develop it. So we had to put the tools together to allow our developers to utilize our CLI to configure an environment as fast as possible, run your test, and then see what's wrong with the test. In the Aqua Framework area, we have different areas that are in different maturities. The current ones in use right now are unit test. It's the normal test that you're familiar with all the upstream gates that we use. We just put them into our CI/CD pipeline for all the changes that we make. We have code analysis we call Aqua Quality. It's basically using Bandit and SonarQube to make sure that the code changes that we make are meeting the security and style requirements that we have. API testing, or Aqua API, is based off of the Tempest framework. The Tempest framework allows us to basically use the upstream resources that are already there to test our deployment and be able to repeat this in the same fashion across our corridors. We also have Aqua Resource, or resource testing. If you look at this and you look at API testing, you sit there on your side and you start doing your API testing. You have your setup and teardown, which is a little mini scenario. As you come across that, you keep on getting more and more scenarios. And we found that ultimately, really what you want to do is that only test the API and the interaction with the API. It doesn't test the resources that are being deployed. So with Aqua Resource, we're actually coming on the control plane and testing those. And we'll get into a little bit more details on that later. Next, the following ones are in beta. Aqua Dashboard, which is basically using OpenStack Helm to take the subunits of SQL and provide a central area that you can look at your test runs for our company. Right now, we're just using it pretty much bare bones out of the box. We've added some extra features to it. Only problem with any reporting tool, as soon as you give data to somebody, there's the next query and next query and next query. So we'll be working to see what we can do possibly in the OpenStack Health area to see if we can put in views. So the next thing is CLI testing, or Aqua CLI. We had a lot of arguments and discussions basically of how to test the CLI. If you test the API, do you need to test the CLI? So we ended up with Aqua CLI, which basically uses the functional testings to make sure that the version of CLI that we're giving to our clients has been tested and works with our deployment. Aqua GUI. Right now, Aqua GUI, we're looking to adapt the Selenium direction for Horizon. Right now, there is a blueprint out there to fix the Horizon tests out there. We would like to work with the Horizon team, and we'll be talking to the Horizon team at the summit this week to see if we can promote getting those back online and giving some resources to help them out, and also trying to promote RBAC first in that area also. That way we can make sure that the RBAC changes that we have out there are basically supported through the UI. Infrastructure testing is basically any of the tests that aren't supported by API. You might want to look at Jumbo frames for your deployment or things along those lines. We're looking at basically a proof of concept for that using our deployment managers and the information that they provide. The final three right here are Aqua Security, Performance, and Resiliency. They're more in the ideation phase. They allow us to make sure that we can scan our environment for security issues. We already do the static code analysis, but we want to basically make sure the environment is working. Right now, our performance test team has their own hardware and things. We're starting to talk about things to see if we can create a performance environment that allows us to start sooner in a corridor and use it repetitively down the corridor. Maybe not find whether you can hit your performance, but if you caused a performance change. If you can find a performance change, then you'll find out in your performance test that you probably have a performance issue. Resiliency, again, a lot of people are doing some things in that area. We'd like to try to see what we can do to standardize that a little bit more so we can then use it across our corridors. Actually, after this slide went through our review process, last week I had a meeting. We actually came up with Aqua Bare Metal. Our lab teams, when they rack and stack a rack and deliver it to us, is working with the Aqua principals to try to put together a series of frameworks and automation tools to guarantee that the rack is basically meeting our design specifications. So when we kick off our deployment process, that there is no underlying network issues or anything along those lines. I'll let Elise talk a little bit about the integration.
Yeah, so how we're integrating our Aqua tests with OpenStack Helm. So OpenStack Helm includes a Tempest chart that can be installed to just perform a containerized run of Tempest. So we have custom overrides for that. So we have custom overrides for the image, Right now, the upstream gate uses the standard image, and within AIC, we're using our Aqua API image that Doug was talking about. Sorry. We're also pushing a new default image upstream soon that will contain all of the core Tempest plugins like Cinder, Heat, etc., and all of the necessary additional components that we need to run the tests. We also can override our configuration values in our values.yaml file, and that's what we can do for every chart within every component of OpenStack, so that's no different, but it is possible. And we also use persistent volumes to store our results so that we can integrate them with our Jenkins instance and do things like visualizations or dashboards.
To do this, you actually either have to count on the Tempest model to meet your needs or put into a repository model to support your needs. And what we've done is we've introduced the concept of integration testing direction should mimic the service and integration tests of the component or strategy of the component. If you do that, then we model basically an internal mirror of the upstream repos, because if you're doing testing, you need to be able to snapshot your tests and be able to run them repetitively, and making sure that as the code goes through the life cycle, that the tests function. So we have to do an internal read-only mirror of the upstream plugins. On top of that, we have to be able to modify tests that we need to meet our testing needs. So we have an internal repository that does that. Currently, we have 11 Tempest plugins supporting 2 different code bases, both Kilo and Okada. The problem is that code is a little bit different. Some of the APIs are different, some of the return codes are different. So instead of having 2 different code bases, we identified those differences. There are 12 in Kilo, there are 5 in Okada, and we basically set the Tempest code as we bring it down and we build our container. We also have a CLI tool that allows our developers to apply those edits onto their code base so they can test it. This allows us to constantly bring down fresh copies of Tempest. When we had our network team submit a change upstream, they got it accepted and merged in. We brought it back down into our internal mirrors, have our own process to test it, and then we merge it into our code base and go forward. That repository model is important for you to be able to use the Tempest tests and to extend the Tempest test to what you need at the time. Automated test packaging and delivery of the execution of the framework. So whenever anybody changes the framework or anybody changes any of our tests, we automatically kick off quality gates, and we also kick off the ability to package that container as a patch set, and then run a test to make sure you haven't broken the framework. We also make sure we haven't broken our standard tests that we go out there. And then that allows the developer, they can grab that test and they can do different things with it if they want to, and assure that the quality of the overall test bit's there.
And we're also working on integrating some custom functionality, one of which is the image build process. So we're working on packaging and publishing each image according to the platform on which we're using it. So for AIC, pre-network cloud, we're using internal web mirrors, and for network cloud, we're using Artifactory. We're also working on creating custom commands for things like associating pre-provisioned credentials to associate with the environment, and that just gives us better concurrency. And then we're also using the CLI for things like temporary resource creation and then tear down of resources, and things like recognizing data leaks instead of cleaning up after data leaks, so that we know when they're happening and we can find that problem and get a solution as quickly as we can.
This is an example of the Jenkins job that runs Aqua API. Once the process is done, we publish these artifacts. Allows you to see what's going on. We do several different things depending on the needs of our clients. We package the actual framework logs. We do a describe call. We wanted to make sure what APIs are being called at what time. So a describe call looks at every Tempest test, uses subunit stream, and gives you back every API call. Helps our RBAC people that are doing the patrol tests to make sure that the proper things are called. We also give different formats of the results, from CSV to JSON to XML to HTML. We contain the subunit stream of a call. That subunit stream allows us to take that. Our test team actually takes that subunit stream and builds their audit report, since the subunit stream contains both the headers in the body of both the request and the response. Then they can prove all their tests, what was sent and what was received. Then we also have the ability to describe the actual test run in subunit, and we use this to basically catch defects. We have one defect where on a teardown of a test, it threw an exception, but the test went successful. We consider, and that's what's actually happening in this screenshot, is this test was 100% successful, but it was yellow because there was a teardown problem in one of the tests. And we ended up going ahead and fixing that. Also, we give you the tempest.conf. We scrub it though. We want to make sure that there's no secrets out there that anybody can see, but at least you can see the configuration that ran your test minus the security or the secrets. We also give you the list of tests and also the Tempest run on the side. This type of approach gives the test team or the person debugging the test or whomever is using this the information at their fingertips at the end of the run. Also, we basically extended, we're trying to make sure that we can basically, let me switch over here. We can basically find out our problem as soon as possible. This is an HTML version of our test report, so it just shows you your success here. This is pretty simple and helpful, but what we want to do is we want to basically help people find problems fast. So what we do is we basically give them some extra information here. Here's all your failures. This is actually the run on the first successful run on our network cloud of the full run of Tempest. There was 120 errors. One was the fact that I turned on IPv6 before it should have been turned on. And there's about 60 of them that are related to our security model, where we basically run our Tempest as admin, and there's 60 tests that if you're admin, you can see things, and it's telling you there's a defect because the member-admin relationship. But the one thing we do here in the failure area is allow you to see what's going on. So in here, we found out that when something failed, we constantly kept on gathering information from this piece and that piece, trying to debug it. So we put it all here. So this one's a pretty easy one. Here's your stack trace, here's your logs, and we give you a regular expression to use with whatever product you're using. We're about to tie this into Prometheus with a hyperlink. So you can sit here, see your problem, hit the hyperlink, bring up the server-side logs and see what's going on. We've learned from the debugging process that when we go through and Glance had a 500 come back to us, we go into Glance server logs, we'll find out that we actually had a network error between Swift, and Swift was not reachable. And so tools like this allow us to basically debug this very quickly. We also give you a skip summary, so you can see what was skipped. The problem is if your environment has changed, you got to be able to summarize this. And we've actually worked with the patrol team to get some of the repetitive values out of these, and we're enhancing this to have a prefix regular expression so we can group these better so you can see what's going on, and then that way you know when you have a particular release candidate, you know what's supposed to be skipped, and that's what's going on here. So let me... Technical.
Different one.
Okay.
Cool. And now I just want to give you guys a brief overview of another one of our Aqua frameworks, which is our resource framework. If you're interested in this in a little more detail, I did a talk about this at the Sydney Summit that was recorded, so there's a full demo there. But just to briefly go over it, Aqua Resource uses existing VNF resource topologies as they're defined in heat. So it uses the OpenStack tool Shaker to run test scenarios. If you're not familiar with Shaker, it's just a OpenStack project that is a data plane network performance testing tool. And so it had a lot of the high-level capabilities that we really were interested in starting this sort of as a proof of concept a few months ago. So we can use custom-built images that have all of the necessary tool sets, so we don't need to spin those up later. And it also uses heat to instantiate the topology. So what Aqua Resource does is it runs our functional tests to make sure that our VNFs and then the cloud architecture that it's running on are playing together nicely. So all of the use cases here are defined just by the VNF teams, and they're absolutely representative of what each team needs since it is developed by the VNF owners. And the results are then reported back to our controller VM and then persist in our Jenkins VM. So from there, we can get our results back and analyze them. And they look something like this. Shaker makes everything packaged together really nicely. A report's provided given metrics for each test. So this one is just for a baseline service chaining test that we use on AIC. And you can see a visualization here of how it ran, so information regarding the bandwidth, some retransmits, and other information all sort of packaged nicely together. And you get this for each test that we're running. And so here are some of the future steps that we're going to take to improve testing for our cloud. So firstly, we want to allow users to further customize their tests. So triggering them when and how they're needed and making sure that everybody gets exactly what they need. We also want to promote integration of custom tools like the image build process and the custom CLI commands that I mentioned earlier to do spinning up and tearing down, scrubbing secrets, etc.
We'd like to also expand the test, either the plugins or Tempest itself. One of the things we have is we're LDAP backed, so we can't create users. We're a really immutable user source. So I'll be working with the QA team and on their Etherpad to promote some of these ideas where we can put an immutable user source and you don't have to blacklist your test. They will automatically skip if you turn that feature on. Also, like I said before on that failure report, 60 of those were basically, since we ran as admin, and it required member to run it, those admin credentials can see something and the test fails. So we need to be able to sit there and say, well, we really need a primary non-admin member and an alternate non-admin member and see if we can go ahead and promote that. We also, Tempest is there to test the API to make sure it's working. It's not really to test your particular deployment. I just brought this up with the QA team about an hour ago of something called expected responses. So you want to make sure that your roles, your flavors, your images are out there the way they're supposed to be. And we can use the Tempest framework to test that. So we're trying to see if there's interest in the community to promote that. We have some of those tests already written inside at AT&T, and we would like to see if we can just move those up and see if other operators can put their tests in there and we can all benefit from that. On top of that, Cinder right now defaults to the default volume type that is on the cinder.conf. It would be nice to increase the framework inside Tempest so you can change your Cinder type. So if you have a LCP, that basically our local control plane that has basically like Solid Fire and Hitachi, you can run the test using both different volume types and test both of your volume backends. Also, we're looking to expand beyond just the Aqua API or the Tempest and look into areas like Resource that Elise just covered and see if we can get a chart up there for that. We are going to work with the QA team to try to improve the Selenium test and get a chart up there, and then also containerizing the existing functional tests to do some CLI testing.
And the last thing we're looking at is making sure that we provide sort of more than sufficient templates and documentation so that it's very clear how to implement the test strategy that you need. And most importantly in all of this, we just really want to work with you all. So we want to make sure that cloud testing, especially within OpenStack Helm, has everything that you as operators and developers need in order to feel confident in your deployment. And so leading in there, if you are part of a large OpenStack operating company or would simply like to listen to some of the concerns and approaches that large operators have or provide some feedback, the LCOO working group meeting will be tomorrow morning at 9 a.m. So there it'll just be a forum sort of brainstorming session to discuss some of our major priorities, which are containerization and quality assurance and security. So we'll be discussing how we can handle these topics, some of our pain points, and how we can resolve them. And everyone is welcome, all interested parties, so we would love to see you there. And thank you guys so much.
We have a couple mics if anybody has any questions for us.
Yep.
Yes.
Would you mind going to the mic?
We're recorded. If you mind going up to the mic.
Thank you.
Thank you.
Yes, so this Aqua tool, it's an internal tool or it's part of OpenStack Helm or?
So basically, the best way I describe it is it's glue. It's the glue of OpenStack or upstream community tools. It's a little thicker in some areas than I would like. And we would like to try to, that's why I was talking to the QA team to promote some of our tooling up into Tempest. We basically, like pre-provisioned credentials, we have to use them. So a lot of that, Aqua is really just the glue of putting this together the way we want. If we can make that glue super thin, then everybody can use those tools and assemble it together. If we find out that there's a common view of how to glue all the parts together, we wouldn't mind bringing Aqua upstream. But like I said, everybody probably wants to run a little bit different tools and stuff. So in the case of Tempest in OSH, we have a standard chart. We just happen to override the image and the test runner. And our test runner inside does a little extra sauce, basically. But we're trying to move that sauce up. So like I said, we dynamically create credentials, okay, or not credentials, but the projects. And so if you're an RBAC tester, we have 10 roles we have to test. We can't run them sequentially, that's 10 hours. So with that tool we put together that takes the accounts.yaml and creates a unique project ID, we can run all 10 together with 8 concurrent workers, and we run in under an hour. So we can test all our roles. So that stuff we don't mind moving up, we just want people to accept it. And this is kind of our talk right here to talk about Aqua and OSH, and basically say, hey, this is out there, more people want it, we'll push it up. And we have a little tool called Roomba. It's our cleanup tool. Yeah, the guy that wrote it is very funny. And so basically that goes and brings down those temporary projects that we created. It also does resource leak detection. And if you leave a resource around, we don't delete that project. And in our framework, we turn it yellow and tell you to go clean up your stuff, because as you go down the corridors, you're going to have to be able to be absolutely pristine and clean.
Thank you.
Thanks for the talk, by the way. Really, really cool stuff. We have similar challenges at GoDaddy, so it's nice to see that people are going through the same things. I agree that the glue kind of has a balance between staying downstream and suddenly getting so heavy that you're tired of carrying it yourself. Mm-hmm.
We need to talk.
Right. My specific question, we've solved these problems in very different ways, but the same model, which is we use Rally instead of Tempest, and we use Zool instead of Jenkins. I'm curious if you've considered them or like contrasted them against yours, or even are aware of how that would relate to it. For instance, Rally has a giant library of OpenStack scenarios, which already kind of is similar to Tempest, a large collection of validation tests. Have you looked at Rally for some of this too?
Yes, we have. Actually, you saw that was a Rally test up there for the chart.
I missed it.
We used that in our chart to validate it. The biggest thing comes down to community support. So we use whatever's appropriate at the time. To your question of Jenkins versus Zool, our CI/CD team would be looking into that, and they kind of give us those environments, and we'll see if there's a value there, especially with the open source of it. We might migrate there, but we'll have to talk about that and the values of what we have today. But from the Rally versus Tempest, there's just a little more community support for the Tempest across more things. Now we still do use Rally if you want to do a load, what I call an unintelligent load against a control plane. You can do that with Rally and stuff. And like I said, we'll use it for testing our charts because it's like you said, a very good tool. It's just that I don't see the community support for the different things that are out there. And like I said, we're trying to even promote different things like RBAC testing using Patrol, and then also what we're calling expected responses.
Thank you.
You're welcome.
Thank you.
Oh, can you walk up to the mic,
Mike?
please? We're being recorded.
Is there a reason why you asked specifically about Zool? Okay, I just came. Okay, no, that's good.
He's my boss.
We just got out of a conversation where like actively looking at swapping out Jenkins for Zool in the next like coming week. So, so if there was something very specific that you thought would be useful, that would be good to know. But if it was just plugging, that's okay.
Have you had scale problems with Jenkins?
We have not, and that's why we haven't moved to Zool yet. But we're we're
open.
as we with the airship projects moving into it. I think that we're kind of all in on the OpenStack projects, and it's starting to make more sense to move and align to Zool. So.
Any other questions?
Cool.
Thank you
Thanks
very much
everyone
for
for
attending.
coming.